Hello everyone, hope you're having a great day. We are going to start with a little quiz review. So get out your review packet. If you don't know where it's at, just stop this, go find it, bring it back. And we're going to do the one called Quiz 8182. So we're kind of just going through the review packet in order. It's on the back of the last one we did. Quiz review, it says Precal A, or Precal C, version A, quiz 8.1, 8.2. So here's our first problem. If you don't have your sheet, you can certainly write this down on a piece of paper, guys. Come on, we're doing a review for a quiz you are going to take next time I see you. Okay? So here is the problem. It's a circle. And even if I didn't know it was a circle, my clue is, the question is, what's the center and radius? So here we go. I'm going to group my x's, group my y's, move the 1 to the other side where it becomes positive, and then of course put my 2 blanks over there. Half of 4 is 2 squared is 4. Half of 8 is 4 squared is 16. So now this little grouping of x's here is x plus 2 squared. And this little grouping of y's is y minus 4 squared. And all that makes 21. So my center, -2, 4, and my radius, root 21. Your quiz that we take next time I see you will have one circle problem on it. May not be the first problem, but one of the 3 problems will be a circle, just like this. Okay. All right, so now we're going to go on to problem 2. On this quiz, problem 2 is an ellipse. So again, even if you don't recognize that equation, look over here what you're finding. You're finding the major axis and the minor axis. That's an ellipse. Okay, so here we go. Let's see what we've got. We've got a center at 2, -1. The 9 here, excuse me, tells me I'm going to count back and forth 3. So 1, 2, 3, 1, 2, 3. And then I have to label those points because you'll see there are 4 little vertices points, 4 little vertex points that you need to find. So let's see, if I count forward 3, this one's going to be 5, -1. And this one's going to be -1, -1. Now, there isn't a grid on the practice quiz. I know that. There is a grid on your real quiz. So if you're having trouble with this, get a piece of graph paper and do it. But I promise there will be a grid on your quiz or graph paper. All right, so here are 2 of my vertices. So I have a vertex at -1, -1, and 5, -1. Now I'm going to count up and down 5. So I'm going to have a vertex up 5, so this is going to be 2, 4, and down 5, that's going to be 2, -6. So those are my other 2 vertices. In any order, the order you write them doesn't matter. You just have to have all 4 of them down there. There you go. Now my major axis My major axis is, I counted up and down 5, so it would be 10. And my minor axis, I counted sideways 3, so it would be 6. Now I need to find my foci. I have everything else. Everything else is identified on there except my foci. So they're always going to be on the major axis. So this time, they go this way, because that's your long axis. They're just on there somewhere. So these red points are my foci. Notice they are straight up and down from the center. So which coordinate will stay the same? If you're moving up and down, then the coordinate that's going to stay the same is x. If I'm moving up and down, I am adding and subtracting from my y. Now, what am I going to add and subtract from my y? Well, in an ellipse, the distance from the center to the focus is the square root of the denominators subtracted. Well, 25 minus 9, ooh, that's nice, is 16. So I am going to go up and down 4. Now, our other examples, we had radicals. This time it happens to be a perfect square, so we're going to go up 4. All right? This is exactly the question Jose asked the other day. If you go up 4, from -1, start at -1 and add 4, you'll be at 3. If you start at -1 and subtract 4, you'll be at -5. So the 2 red points, 2, 3, and 2, -5 are my foci. Those are my foci. Remember, if you need more practice, you can always stop the video, recopy the problem on another paper, and see if you can reproduce it. If you can't, then rewind me and play all this again. Last problem. Remember, the quiz is going to have 3 problems. A circle, an ellipse, and a parabola. So here's our parabola. Vertex, oh my goodness, folks, vertex, 3, -4. Everybody gets that right. Focal width, everybody gets that right. Nobody misses those. Those are gimmies. Which way do I open? Which way does this parabola open? X squared, positive 16. That means we open up. My focus is going to be straight up then, straight up from my vertex. And the directrix will be straight down from my vertex. Now, where is it? Well, I have to know how far to go up. Now again, it's just like the problem we did a minute ago. If I'm going straight up, my x isn't going to change. I need to figure out what my y is. We call that p, or that distance is called p. So in this problem, 4p is 16, which means p is 4. So I'm going to start right here at -4, and I'm going to add 4. I'm going to go up 4. Well, -4 plus 4 is 0. So my focus is actually at -3, 0. Nobody is grading your picture. Over in the answer blank, put 3, 0. Start at your vertex, -4, and go up 4. You're at 0. Now, start at your vertex and go down 4. -4 minus 4 would be -8. So this is the line where y equals -8. That's your directrix. That is your directrix. Okay? All right. So like I said, you've got tons of practice problems. You've got circles, you've got ellipses, you've got parabolas. Go back to your notes, recopy a couple of them, make sure you can get the right answer. Okay? If not, come back and watch this video or watch another video and work through them till you're confident that you can do these 3 problems. Okay, now let's set that aside and let's get out our notes. And let's begin our last conic section, which is the hyperbola. The hyperbola. And we'll start like we always do, by a definition. I'm going to write this definition down, and then I wish you were here so you could tell me what you notice about it. The definition of a hyperbola: a set of points in a plane. All of our definitions start that way. Guys, it's right up here, the top of the notes. This is where we write our definitions, because we got to know them. So the set of points in a plane, the difference of whose distances from 2 fixed points is constant. Okay, get that written down. That definition looks exactly, word for word, like your ellipse definition. The only difference is in the ellipse, remember what this word is? This word is sum, S-U-M. In the hyperbola, it's difference. What does difference mean? Difference means subtract. I want you to think about your ellipse equations. Don't your ellipse equations look like this? Aren't your ellipse equations a sum? Well, look at this. This is a hyperbola. It is exactly the same equation, only instead of a plus, it has a minus because its definition is difference. And just like with the ellipse, these 2 fixed points are called the foci. All right, here we go. You're going to love this because so much of it is similar to the ellipse. So this is kind of good practice for us. Okay, where do you think the center of that is? Take a look at the X and the Y. No parentheses. That means the center is going to be at the origin, just like always. What are we used to that 16 telling us? How far left and right? So we're going to go 1, 2, 3, 4. 1, 2, 3, 4. And then I'm going to go up 2, down 2. Now, here's the first difference. So far, everything's the same. as with the ellipse. In the ellipse, once I did all those points there, I connected them with a nice oval. In a hyperbola, you're going to connect them with a rectangle. So you're doing the same, you're getting the same points the same way, but you're going to draw a rectangle. Then you're going to draw in the diagonals of the rectangle. And extend them through, extend them out. Okay, you're drawing in the diagonals of the rectangle. These diagonals are called, let's see, I gotta label it over here. These diagonals are called the asymptotes. We had asymptotes before when we graphed our tangent. These are the asymptotes. Note the spelling of that word, and the P is silent. Asymptotes. Two of them. Once you get the asymptotes drawn, then we're going to draw in our hyperbola, and here's how you do it. If x comes first in the equation, with hyperbolas, it's all about who's first. If x comes first in the equation, then your hyperbola is going to open sideways in the x direction. Okay? So notice I'm starting, it's like a little parabola sideways, but the vertex is that point right there on the box. So here's the other one. And we follow those asymptotes. We just get closer to those asymptotes. The purple thing is the actual curve itself. That is the hyperbola. What the asymptotes do is they're my guidelines. They're my guidelines. If the equation had been switched and y were first, then I would be starting at this point and drawing an up and down hyperbola. We'll have one of those in a second. Okay, now, got a whole bunch of stuff we're supposed to list. These purple dots right here, the dots that are on the box that act like the vertices of the parabola, those are called the vertices. So these 2 points are the vertices. There's only 2. So I have 2 vertices. Those 2 points, remember how I got them? I counted forward 4 and backward 4. So those 2 points, you're doing it on graph paper, those 2 points are negative 4, 0, and 4, 0. In either order, it doesn't matter. Now, remember how the ellipse had a major axis and a minor axis. The hyperbola has 2 axes also, only the axes are called transverse and conjugate. And it has nothing to do with length. The transverse, look right here, verse, the transverse axis is the one that joins the vertices. So it doesn't matter if it's long or short, that's irrelevant. It's vertex to vertex, across the vertices, transverse. So how long is the transverse axis? 8. I went back and forth 4. So the transverse axis is 8. Now, what about the conjugate axis? Well, it's the other one, the other dimension of the rectangle. So we counted up and down 2. So the conjugate axis is 4. So again, in an ellipse, it's all about who's the biggest. In a hyperbola, it's all about who is joining the vertices. Okay, so I'm kind of keeping track of everything I was supposed to find here. Now I need my foci. Well, if you think of this as like a parabola, doesn't it make sense that the focus would be right in here, inside the curve? That's where they are. They are inside the curve. So after you draw in your hyperbola, then you'll know where your foci are. They're inside the branches of the hyperbola. Now this is the tricky part. When we measure, we're going to find a distance in a minute. In order to find that, we're going to find out how far we have to go. We always start measuring from the center. So I know there's another point in here, don't use it. We want to know how far that distance is. Okay, so I'm going to start at 0, 0, and I'm going to add to my x because I'm going sideways. So my y is going to stay the same. I'm going to erase this now. My y is going to stay the same, both sides. But my x is going to be moved because I'm starting at 0 and I'm moving all the way to here. Now, what is that distance? Well, you remember in an ellipse, center to focus is found how? Subtract the denominators and take the square root. In an ellipse, we're going to add the denominators and take the square root. So that's going to be the square root of 16 plus 4 in a hyperbola. We're going to add, get the square root of 20, which is 2 root 5. You need to add those two numbers, kids, because you got to move past the purple dots. You got to get outside of the purple dots. So you have to add those numbers. Okay, so I'm going to start at my origin, which is where x is 0, and I'm going to add 2 root 5 to get to my green dot. Well, 0 plus 2 root 5 is just 2 root 5. So that focus is 2 root 5, comma 0. This one will be 0 minus 2 root 5, so negative 2 root 5, comma 0. Those are my foci. There's a lot with hyperbolas, there's a lot. All right, now I need the equations of my asymptotes. Okay, now I'm gonna have to erase some stuff here. I got too much, no room to work. So, the asymptotes are lines. To write the equation of a line, you need a point and you need a slope. You have both. The point you're always going to use is the origin, 0, 0. And the slope that you're going to use is how you built the box. So think about it. We started right here. And we counted up how many? 2. And over how many? 4. So the slope of this line is up 2 over 4, or 2/4, or 1/2. So the slope of this red line, up 2 over 4. That's how I built the box. Now, what about that red line? Well, it's the same thing, only it's up 2 and left 4. So that would be negative 1/2. So your asymptotes are always going to be the same number, one positive, one negative. Because you're always going up and right, and an up and left, the same amount. So now I'm going to use my point slope form. Good review. Y minus my y equals m times x minus my x. So y minus 0 is just y, 1/2 x. So there is one of my asymptotes. It's actually this one. You don't have to identify that. It's just write down, there's going to be two of them, two asymptotes. One of them is that. The other one, I'm going to use my negative slope, so it'll be y minus 0 equals negative 1/2 x minus 0. So you've got 1 point, 2 slopes, but the slopes are always the same number. One's positive, one's negative. All right, so y equals negative 1/2 x. And there are the equations of my asymptotes. Wow, that was one problem. Whew. All right, that's A. Let's take a look at B. Okay. B is where's my center? 0, 0. Now this is another one of those trap problems. It doesn't really matter in this case, but 0, 0. X, Y. So if these had parentheses, it would be this number first. Always X, comma, Y. So my center's at the origin. Now what does that 9 tell me to do? That 9 tells me to count up and down 3. And the 16 tells me to count sideways 4. So far, so good. At this point though, don't make an oval, you're going to make a rectangle. And then you're going to draw in the diagonals of the rectangle. So corner to corner, and it goes through the center. There we go. Now it's time to draw my hyperbola. Two like parabolas going opposite directions. Remember that the vertices, the parabola, opens in the direction of the letter that comes first. So the letter that comes first is Y. So up 3 right here, 0, 3. Down here, 0, negative 3. Those are my vertices, and this is what my hyperbola looks like. Remember, they open up and down, or left and right. And it depends 100% on which letter comes first in the equation. Okay, so if you know Y comes first in the equation, then you're opening up and down, just like this. So far, I've only really concretely answered 2 questions. My center is at the origin, 0, 0, and my vertices, there are 2 of them, my vertices are at 0, 3, and 0, negative 3. That's all I've answered so far. Okay, now remember, your transverse axis, just look at the word. Your transverse axis joins the vertices. So how long is that one right there? that is 6, because you went up 3 and down 3. The other one is the conjugate axis. That's this way, and we counted over 4, so that one is 8. Again, it doesn't have anything to do with length. In this case, the transverse is shorter than the conjugate. That's just how it is. Okay. Now I need my foci. All right, so where are they? Remember, they're always in here. They're inside the parabola, the hyperbola. They look like parabolas when they're individual. Okay? Now, I need to find out how far down I'm going to come, or how far up I'm going to come. It's the same. Go up and down the same amount to get to your focus. But you're starting at the origin. You're starting at your center. Okay? To find that distance, center to focus, we're going to add our denominators and take the square root. Well, this one worked out nicely. That didn't happen very often. Didn't happen in the last example. We have 5. So we're going to start at our center and add, which, by the way, since I'm going up, my x is going to stay the same. I'm moving this way, so my x is staying the same. So I'm going to take my original y, which is 0, and add 5 and subtract 5. Those are your foci. So in the blank for foci, that's what you put. Okay? Now, let's select asymptotes. I need the equations of my asymptotes. So to find the equations of my asymptotes, I need a point and I need a slope. Now I know my slope, I'm going to get 2. Positive and negative, okay? Now the point you're always going to use is the origin. I shouldn't say it. The point you're always going to use is the center. And since the center is the origin, I'm using that as my point. We always start at the center. Your slope is how you built the box. Well, how did we build this box? Well, we counted up 1, 2, 3, and over 1, 2, 3, 4. So your slope is positive 3/4 for this line and negative 3/4 for that line. So plus or minus 3/4, that's your slope. So now we can write the equation of our asymptotes. Point slope, y minus the y equals 3/4 x minus the x. So y equals, since y minus 0 is just y, 3/4 x. And then y minus 0 equals negative 3/4 x minus 0. Point slope form, y minus y equals m x minus x. And y equals negative 3/4 x. So there are the equations of my asymptotes. And I think I've answered all the questions then. Okay? All right, let's try the next one. These things take the whole board. All right, so what's my next one? X squared over 4 minus y squared over 25. Okay. Where is our center? That's the beginning of everything. Our center is at the origin. We're going to count sideways 2 and up and down 5. We're going to draw a box. And then we're going to draw in the diagonals of the box. And then we're going to draw our hyperbola. Now remember, the hyperbola is going to open in the direction of its first letter. So the first letter is X. So this hyperbola is going to open, oh, it's very fat. It's going to open on the X-axis. So these big purple points are the vertices. Those are the vertices. So what will they be? Well, you plotted them. So you start at the origin, you counted forward and backward 2. So they're going to be at 0, 2, 2, 0, and negative 2, 0. Now, this is the transverse axis. These are the vertices. That's the transverse axis. So the transverse axis is 4. And the conjugate axis is up and down 5. So it is 10. Now we need our foci. They're back here somewhere. There was inside the curve, so here's the curve, so they're inside of it. From the center to the focus, remember how we find that? We add our denominators and take the square root. So that's going to be the square root of 29. So this distance right here is the square root of 29. Now notice I'm going which way? I'm going sideways. So my X, this is my center here at 0, 0. My X is going to change. 0 plus root 29, 0 minus root 29. But my Y is not going to change. My Y is just going to stay 0 because I only went sideways. So those are your focus points, your 2 foci. Now we need the equations of our asymptotes. I need a point, 0, 0. We're not always going to use 0, 0. We're always going to use the center of the circle. And then I need a slope. My slope will be, when I built the box, I counted up 1, 2, 3, 4, 5, and right 2. So my slope is either positive 5/2 or negative 5/2. I counted up 5 and over 2. So my equations, y minus 0 equals 5/2 x minus 0. Y minus 0 equals negative 5/2 x minus 0. When I clean those up, the zeros kind of disappear, so y equals 5/2 x, and y equals negative 5/2 x. Y minus 0 is just y. X minus 0 is just x. Okay, we're getting a little faster here. Last one on this page. Here we go. Make sure I copied the right problem here. There we go. Okay. Once again, our center is at the origin. But once again, it doesn't matter in this problem, but if there were parentheses, it would be a big deal. It's x comma y. So it's 0 comma 0. I'm going to count up 1 and over 3. Everybody agree with that? Then build the box. Then draw in the diagonals of the box. Nobody's grading your picture. Don't worry about it. Now, draw in the curve itself, draw in a hyperbola. Keep in mind that it opens in the direction of its first letter. So this is going to be a Y. This is going to be an up and down, vertical. So this is my vertex. This is my vertex. The points on the axis on the box there, those are your vertices. This one is extremely fat. And the vertices are 0, 1, and 0, negative 1. Again, when you started building this thing, you started at the center, the origin, and went up 1 and down 1. Those are your vertices. This is your transverse axis. How long is it? 2. This is your conjugate axis. Oh geez, now I have the hiccups, sorry. This is your conjugate axis. How long is it? 6. Where are my foci? Well, they're always inside the curve. So they're going to be here and here. Now, this is the origin. Because I'm going up and down, x isn't changing. So x is going to stay 0. But what's going to happen to y? I don't know. I got to figure out how far it is from the center. Make sure you're starting at the center. How far is it from the center up to the vertex or focus? Well, center to focus is found by adding your denominators and taking the square root. So I'm going to start at 0 and go up root 10. So 0 plus root 10, 0 minus root 10. Those are my foci. Now I need my asymptotes. I need a point and I need a slope. The point is always going to be your center. The slope is how you built the box. You counted, remember slope is up over over, so it's y over x. So I went up 1 and over 3, so my slope is either positive or negative 1/3. Up 1 over 3. Up 1 over 3. Point slope form, y minus 0 equals 1/3 x minus 0. And y minus 0 equals negative 1/3 x minus 0. Clean them up. Get rid of the zeros basically. So y equals 1/3 x. And and y equals negative 1/3 x. All right, now that's all I'm going to do for that, because I want to pause for a moment, and because we've been doing the hyperbolas, I don't want you to get that mixed up on your quiz. So we're going to do now an extra practice ellipse problem. So this is, I'm making this up right now on the spur of the moment. This is nowhere in your notes. Don't be digging around looking for it. Find a piece of paper that you can write on, and we're going to practice one more ellipse problem for our quiz next time I see you. All right, so here we go. This is going to be our ellipse problem. So again, we're starting the hyperbola now, but hyperbolas are different. They're different shape. Hyperbolas have a minus here. This is an ellipse. The center of this ellipse is where? Negative 1, 3. Again, this is additional quiz review to get us back in the mindset of ellipse. I just did 4 hyperbola problems, so now we're thinking about an ellipse. So negative 1, 3. The 25 tells me to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Up and down 2, 1, 2, 1, 2. Now, in an ellipse, guys, you connect these with your nice little oval, and all 4 of those points are the vertices. So you got to find them, all 4 of them. So remember where you started at negative 1, and you counted forward 5. Well, negative 1 plus 5 would put me at 4, comma 3. Notice I'm going on the x direction, so y's staying the same. Negative 1 minus 5 be negative 6, comma 3. You have graph paper. If you don't understand where these numbers are coming from, on your graph, count the spaces. You can label those points. They're on your graph. And if they're not, they should be. So I have 4, 3, and negative 6, 3 as 2 of my vertices. Now I need these 2. Now I'm going up and down. So that's going to be negative 1, comma something. I'm going up 2, so that'll be 5, and down 2, that'll be 1. So negative 1, 5, and negative 1, 1. Again, count it on your graph. Those are your vertices. Your major axis, that's the long one, is 10, because you went back and forth 5. Your minor axis is 4, because you went up and down 2. All that's left, these are easier than the hyperbola, all that's left are the foci, and they are on your major axis, so they're going to be out here somewhere. They're points. 2 of them, 2 foci. Here's your center. You're going sideways. So the y is going to stay the same. So your y coordinate is going to be 3. Half credit for getting that right. So pay attention. Get the 3 right at least. Then what's this distance? Well, in an ellipse, the center to the focus is the denominators minus each other. So 25 minus 4. So that distance is the square root of 21. Now that does not mean that number is root 21. It's not. We're starting at -1 and adding root 21 to it. So -1 plus root 21, comma 3. That's that focus. And then this one, we're doing the same thing. We're starting at -1, but we're backing up root 21. So -1 minus root 21, comma 3. Those 2 points are your foci. All right, well, like I said, you got a billion practice problems. Go back and recopy them on another sheet of paper and redo them. Practice, practice, practice. Thanks, guys. Have a great day.